6.5, which is the average value of a function. Here's the formula right here. The integral, it's good to think of the integral as a sum. So integral can be thought of, not exactly, but it can be thought of as the sum of infinitely many values. Okay, so the sum of all the values in this interval, but well, it can sort of be thought of in that way, but you're multiplied by dx. Okay, so if you think of it this way, then you kind of, if you try to rigorously do this, then you run into a lot of trouble, because these f of x's, you're summing up an infinite number of values, but then because these dx's are really small, you're multiplying by 0. So you're basically, it's infinity, but this is multiplied by 0. So you kind of run into problems if you rigorously try to do that way. Okay, but you can think of it that way, though, that the integral is sort of just adding up all the values. And so if you're adding up all the values, right, this is like adding up all the values, and then you divide by the length of the interval, then you're getting an average, the average value. And it works out pretty well as far as, if you look at the graph and everything, that works out pretty well. So, and then there's the mean value theorem for integrals. That is, if you have in order for this to work, the function has to be continuous. If it's not continuous, this is not going to work, or not necessarily going to work. Okay, so if it's continuous, then it means it's integrable. You can take the integral. You can take the integral of things that are not continuous, but if it's continuous, you definitely can take the integral. And the conclusion is that there exists a number c such that f of c is equal to the average function value. Okay, and we'll kind of like illustrate this further on with one of the exercises. But first of all, let's get to this part right here where we calculate some integrals. We calculate some average values. Okay. So number 1, find the average value of this function on the interval from 3 to 7. Okay. So again, the average value is going to be 1 over the length of the interval times the integral from a to b dt. So I plug everything in. It's 3 to 7, so this is going to be 1 over 7 minus 3, or you can just take the difference there. 7 minus 3 is 4. It's going to end up being a 4. And then here we have, now it's t divided by that, but I like to write it this way, just because taking the integral becomes easier. That's 1/4, like I said. Here, again, the way they do this derivative, if you do a u substitution, if you're familiar with that, you can let u be 7 plus t squared, and then du will be 2t dt. So the t dt gets taken out. Alternatively, you can just, like I do, you can just guess at the integral. Because this is the main part, you have this t coming out. The derivative of this inside part is 2t, and there's your t right there. Then I'll just take this. It's raised to the -1/2, so I'll add 1 to that, so that's 1/2. Okay, and then think about taking the derivative of this. If I take a derivative of this, a 1/2 will come down, right? So if I counter that with a 2, then this will cancel that coming down. And then also, this will be reduced by 1 power to -1/2. So 1/2 minus half is -1/2. So you'll get all this term right here. But also then you take the derivative of the inside part, and the derivative there, you're going to have a 2t coming out. Well, the t goes there. There's the t right there. But I counter that with a 1/2. That means that this 1/2 will cancel that out. Unfortunately, these are just going to cancel each other out. So the answer would be, it's just going to be, it's just going to be this. So 1/4, 7 plus 2 t squared to the 1/2. Or the square root of 7 plus t squared. Evaluated from 3 to 7. Okay, so that's going to be the square root of 7 plus, okay, when you put a 7 in here, that's 49, minus the square root of 7 plus, and 3 squared, that's going to be 9. And square root of 56 minus the square root of 16. Now 56 is, you can factor 4, it's 4 times 14. So you'll have a and the square root of 16 is 4. So that gives you, and this it'll come out as a 2 root 14 minus 4. That's a 4. And then that's, so you get if you distribute the 1/4 then finally you get root 14 over 2 minus 1. Okay, any questions about that? Any concerns? Okay, let's go on to the next exercise. Find the average value of the function, of this function on the interval from 1 to 5. Okay. So now, hey, that's kind of spells the word have. Oh well. So you divide by the length of the integral. In this case, it's 4. That's, you get 1/4 there. And you're integrating from 1 to 5 of log of u over u. I guess this section is more like just a practice of integration to try to help you bring up your integration skills. The way that I look at this is if you take the derivative of this, you get 1 over u. So you get this piece here. So that means that I can take the integral by looking at something like that, okay? So because when I take the derivative, then this 2 comes down. This reduces by 1 power to get me that. And then the derivative inside is 1 over u du. So it gives me that and that. Okay, so this piece comes down, and it's going to be 2. So I can counter that with a 1/2. Okay, so when that 2 comes down, this 1/2 will cancel it out. So to leave that 1/2 there. And then this reduces by 1, so I'll get this piece. And then the derivative inside is 1 over u, so I'll get that. Okay, so it's going to be 1, and that's evaluated from 1 to 5. Okay, so it's going to be 1/8. We'll go ahead and put the things in. Log of 5 squared minus log of 1 squared. And log of 1 is just 0. That's 0. So the answer here is going to be 1/8 times the natural log of 5 squared. Okay, do you guys have any questions or concerns about that one? Okay, great. We'll move on to the next one, number 3. Here you have this function 10 sine x minus 5 sine 2x on the interval from 0 to pi. And we're supposed to find the average value of f on the interval. Okay, so again, that's going to be 1 over pi, because this, the length of the interval is pi, so that's 1 over pi there. And you're going from 0 to pi, and you're integrating that. So 10 sine x minus 5 sine of 2x. Okay, great. So now we get to integrate this. So integrating that, the integral of cosine x is negative sine x. So we'll put a negative right there. This one is also, well, the derivative of cosine 2x. From here, you're going to get a 2 coming out. So I'll counter that with a 1/2. Like that. Okay, great. So now let's put a pi in. So negative 10 cosine pi. Oh, this is going to be a plus here. I'm sorry. I forgot to put the sign. Because when you take the derivative of cosine is negative sign. So that will make that plus or minus. Okay. So plus, and then we have 5/2 cosine of 2 pi. Okay, minus negative 10 cosine of 0 plus 5/2 cosine of 0. Okay, so let's evaluate everything. Okay, first of all, this right here, this is negative, okay, cosine of pi is negative 1. So this is negative 10 times negative 1. Cosine of 2 pi is 1, so that's going to be 5/2. Okay, now we have a minus, okay, cosine of 0 is 1. So that's going to be minus a negative 1. So that's plus 1, or plus 10, I'm sorry. And then you have minus, cosine of 0 is also 1. So you have minus 5/2. Yay, and this is my favorite part, by the way. Those cancel out. Then we're left with no fractions whatsoever. Okay, so 10 and 10 is 20. So 20 over pi is the average value. Okay, let's move on to part B. So part B finds C such that F average equals F of C. So basically for this one, you're looking where to solve this right here. And you should realize pretty quickly that you really can't do this by hand, that you'll need some technology to do it with. Because using trigonometric functions to get, like, you know, a combination of trigonometric functions to get 20 over pi, that's just not something that really comes up. So so what I like to do is use Geogebra, as some of you know, they've taken the class before. So I'm going to go ahead and go over to, we're going to go ahead and explore Geogebra. Okay, so here is, you guys can see this, right? Geogebra. And it's a website, geogebra.org. and you go to that website and then you go to start the calculator, or you can do graphing calculator or whatever, or CAS calculator, or just any calculator from the Geogebra. Okay, and basically what it is you have these commands over here, and then you have a graph over there. So if I put in the first one, 10 sine of x minus 5 sine of 2x. Okay, so that's the first function right there. And really, though, we're interested in from 0 to pi. So from 0 to there, from here to here, this is the interval that we're interested in. And unfortunately, if you zoom in, then you kind of lose the y scale. You lose this part right here. I guess you can like go up and look at it. It looks like it tops out at 12.99. Maybe that's 13. Maybe not. Probably not. Okay, so you're looking at that, and you're looking at what the average value. So 20 over pi. So if I type pi, that's pi, and that is going to be this up here. Now sometimes I don't know what I'm doing wrong, but or maybe it's I'm using the wrong calculator for them to get intercept. But those are the two places. So this is where these points of intersection here are where the function intercepts with this average, because the average value is 20 over pi. So those are where it intercepts. Okay, so to get those values, I'm going to do this. I'm just going to go 10 sine. Well, I can just go. I can just fix this one. I can just go back up to that one and go minus 20 over pi. Pi for pi. Okay, and I change that, and so then just delete that one because it's confusing. So this is where where this one is this one right here is where it intercepts the x-axis. Those are going to be the answers. So one answer, and I can click there, and it shows me what it is: 1.238. It's one of 3 decimal places. So 1.238 is one answer, and then over here, 2.808 is the other. Okay, so remember those values, and we'll go back to the document. So essentially from Geogebra, maybe I'll write some intercepts of f of x minus 20 over pi. 1.238 and 2.808 are the two answers right there. And then the third one was to sketch the graph and the rectangle whose area is the same as the area under the graph. And that one is going to be this first answer here. And you can tell from the graph that we drew, it was going up like this. It was kind of distorted because it went really high, but it just started out kind of flat and went up like that, and then just did the clean cut through here. And of course, this graph and that graph are the same, but the rectangles are different, because this rectangle here is at this is about 20 over pi right there. And so this rectangle, the average value times the area under the curve. No, the area under the curve is equal to the average value times the length of the curve. Okay, that goes back to this right here. Okay, so the integral is equal to the average value times the length of the curve. And this right here, this quantity here, is the rectangle. It's the area of the rectangle from 3C. Okay, the average value times the average value times the average value here times the length of the curve. Okay, and that's equal to the area under the curve or the integral. Okay, so number 4. Moving along. Okay, suppose the world population in the second half of the 20th century can be modeled by the equation. That equation. Use this equation to estimate the world population to the nearest million during the time period 1950 to 1980. Okay, so I had a lot of trouble with this problem, and that is because I didn't realize a couple of things that aren't here. The first one being that this is in millions. And also, the second thing is that 1950 corresponds to t equals 0, and 1980 corresponds to t equals 30. Okay, so 1980 is 30 years after 1950. Okay. So you're supposed to use this population, use this equation to estimate the average world population to the nearest million. Okay, so we're looking at p average on the interval from 0 to 30. That's basically what we're looking for. So that's going to be 1 over 30, because the length is 30. And so integrating from 0 to 30 of P of t, which is 2,560, e to the 0.017185t. Okay, so we can go ahead and integrate that. Okay, so the integral of, if you take the derivative of this, then you're going to get this times, you know, because this part's going to come down. So you're going to be times that. So what I'm going to do is I'm going to put this underneath. Okay, so now when I take the derivative of this, I'll get this piece, and I'll get these constants. And then, but then I'll have to multiply by the derivative of this part up here, which it's this number times t, so the derivative is just going to be this number, but it will cancel with this red one that I have there. And that's going to go from 0 to 30. Okay, so what all that is 2560 over 30 times 0.017185. Okay, now I'm going to plug a 30 in. So I'll be plugging 30 in here. So I'll get all these things times this raised to the 0.017185 times 30. Okay, then subtract and plug a 0 in, and e to the 0 is 1, so that's just going to be 1. Okay, so I get that, and evaluating it, let me find my calculator here. Okay, 3,349.5 0.571711, but you round that to the nearest million, so 3,350.